Hello, everyone. Thank you for joining us today for another webinar in our product feature series. We've ran a few of these in the past, and we featured our medical physics specialist at Adaptive, Borko Basiric, and he's joining us again today to take us through the new features in version 3.0 of our software module for our high dose rate brachytherapy applicator. I'm Rohit Seth. I'm the director of marketing here at Adaptive, and just like to let everyone know that we're broadcasting live from our homes separately today as we work from home and navigate through these challenging times that face us all. We've encouraged and instituted a policy at Adaptive to work from home. So I hope everyone out there is safe and doing okay. And without further ado, we'll get started here. So as I mentioned, our brachytherapy module is one of the three that we offer in our software. It has regulatory clearance with FDA 510K clearance and a CE mark. We provide cancer centers with an in-house solution. So not just a 3D printing solution, but we also offer the software and filament materials along with the 3D printer, all of which have been fully validated for use in radiation oncology. We directly integrate with your clinically commissioned TPS. This allows you to optimize the fabrication process through digital design, where you can import the DICOM files into our software and then back to the TPS for validation and for quality assurance. We also allow users to reduce the time and skilled labor that is required to produce an applicator that can be used clinically. So there's some major advantages, and I'm actually going to run through that one and some more before we get to Borko and him showing us the new features in our software. So as I just mentioned, using our software to design Brachy Applicators overcomes the challenge of time-consuming manual fabrication methods. A lot of times often requires some really creative arts and crafts, which I'm sure you can all attest to, and those can only be done by a highly experienced staff. Accuracy and precision are superior with digitally designed 3D printed applicators because they are patient-specific and they conform exactly to the patient anatomy. So the fit is superior, and dose uniformity is improved along with patient comfort. So everything we do at Adaptive is for the patient. I'm sure all of you do. Patient experience and patient comfort is paramount when we are designing anything in our software. The 3D printed applicators that we do design, or that you can design in our software, are produced at a fraction of the cost of traditional applicators, such as the Freiberg flap, which I'm sure all of you have either used or know of, and they can be quite costly. They're quite fragile too, so you can reduce any risk or vulnerability with manually fabricated applicators that take a lot of time to produce. So if an applicator that you've created by hand is broken or lost, you go back to the drawing board and have to redo them. But the speed with which a 3D printed applicator can be reduced is really easy, easily reproduced, and can be done in a matter of hours. So we take that risk away from users by using our software. So as I mentioned, our presenter today is Borko Basiric. He's a medical physics specialist here. If you've attended any of our past webinars, you know of him well. He's a product owner of the brachytherapy solutions here at Adaptive, so that means he's had a hand in developing and doing the QA from a medical physics standpoint for our applications. And he has a vast, wide-ranging experience. So Borko was born and raised in Serbia, and he worked there as a medical physicist in the clinical field, and then moved to Canada, to Toronto, Ontario, where he worked at a hospital there, again in the clinical setting. And then a couple of years ago, he moved to Halifax, Nova Scotia, where he currently is now working for Adaptive, where we're based. So he's been able to work in both clinical and now in the industry environment. So he brings a wide range and great knowledge and background when it comes to not only brachytherapy, but also medical physics. So Borko will now take us all through our software and the new features and enhancements that have been made. So I'll hand it over to you, Borko. Take it away.
Thanks, Rohit, and thanks for this lovely introduction. So without further ado, as you said, let's just jump into the the module and the Surface Brachytherapy applicator and its design. So let's just upload the data set. And for those of you who are not really familiar with 3D bolus, the designing of the Surface Brachytherapy applicator, for that design, we need a DICOM data set, which contains CT images and RT structure set, which contains the body RT structure and the applicator RT structure, which can be designed in any commercially available TPS, whether it's external beam or brachytherapy TPS, and exported from those. So here we're dealing, as I said, with DICOM data, and using the RT structure of the applicator, we can actually make a 3D object of the applicator and then go into designing the source trajectories, which will be later subtracted into catheter tunnels. Okay, here in this, I would say step one of the whole workflow and designing of the brachytherapy applicator. We have the trajectory set up, and for all of those of you who actually watched our previous webinar on surface brachytherapy, know what I'm talking about when I'm talking about different features and settings about the design. But I'll just quickly go through with these design or with these settings that we have here on the right-hand side of the panel. We can actually design and place these trajectories in any kind of orientation, or place them in any part of the applicator. We can actually tailor the intertrajectory distance and surface distance, which are basically separation and standoff distances, which we can influence on. Of course, change the number of trajectories and the tunnel radius, which will be the tunnel will be subtracted later. So this tunnel radius for catheter to fit in can be manipulated through this feature. So all of this is like an added value to the software, which means we can tailor the design of the surface brachytherapy applicator towards the best possible and towards the clinical needs. Today, I will be specifically talking about new features that we implemented in the version 3 of our software. And there are 5 features that we implemented since the last version and a new workflow that I'll be talking about. So let us jump to the first feature which we implemented, which is a 3D view of the RT structures. So here on the right-hand side panel, we can actually update the 3D view with any of the RT structures that are imported through RT structure file through DICOM. And as you immediately see, the benefit of it, we can actually visualize the target volume for this plan, which is very highly beneficial, because if we can actually visualize target volume, we can tailor the source trajectories, or we can design them in respect to this 3D view of the target volume, which is highly beneficial. I must say that this feature and most of the features are coming through our cooperation with our clinical users and clinical partners, and I'm really satisfied with this cooperation, where any kind of clinically beneficial settings and features can be implemented in the future installments of the 3D bolus, just by making this clinical collaboration. Within this feature, we can actually use like this transparency bar, and which is just like a standard feature, which can be which is introduced in any kind of commercially available TPS. Okay, so the second feature here that we will introduce is the brachycurvature mode. Okay, so with the previous versions of our software, especially when sculpt cases were used, our trajectories in some cases ran to, our algorithm ran to a limitation and itself. So these exit trajectories in some cases were converging towards each other. So the separation could not be properly maintained on the exit trajectories, but only on these very, very curved surfaces and, these difficult cases like scalp. So we now provide like additional we call it the brachy curvature mode, which is kind of an additional algorithm that instead of the separation, like a constant separation, which happens on the surface itself, this time we can introduce this brachy curvature mode algorithm, which kind of makes separation between the planes in which these source trajectories are designed. So this enables us to make, I would say, constant interplane distance between these trajectories and use these or use this basically algorithm on the very, very difficult cases, which are scalp and like all the cases which have like applicators, which have double curvature and are anatomically demanding to actually use our algorithm on. So specifically, we came with this brachy curvature mode where we actually, where we are covering the most difficult cases in terms of applicator curvature and patient anatomy. Okay, so besides these features that I'm mentioning, also we incorporated a new UI UX design. It's very similar to the old one, but there are a few very, very different and I would say much more user-friendly features that we incorporated. And one is that we kind of, call the hand-holding of a user, where we actually incorporated these steps, one of 7, or actually 7 steps, where we are currently in the step 1, but where when user has a perspective of where they stand in terms of the whole workflow, it's much easier to navigate through the whole modules and all the features that it has built in, and we'll see there are quite a few features built. So having these steps clearly shown here, I think very much aids into the overall feeling of like user friendliness and workflow within this app. Again, all these settings and advanced settings I've been talking previously in our last webinar, and this webinar you can also find on our YouTube channel, so Adaptive's YouTube channel. And as I said, today I will mostly focus on the new features that can be found in the version 3.0 of our software. So let's just go maybe to the next step. So we kind of generate trajectories, and here we see the generated trajectories, and we see something that I was explaining the last time, that 3D bolus and its Brachytherapy Surface module is the only piece of software that can show you the minimum bend radius of the curvature. And of course, with our software and advanced settings, you can actually commission that minimum bend radius, which is actually connected to the minimum bend radius of the afterloader and also to the radius of the catheters used. So our app and our module has it's the only module that, or piece of software that has ability to show you whether a piece of curvature on any of the trajectories has a radius of curvature less than a minimum set threshold, which is like a big safety feature, before you ever go to the afterloader and, use a dummy source or a radiation source to go through. So this is a big safety feature which you can actually influence on manually, so we can manually fix these. But as I said, there is a whole other webinar on this one, so I encourage our listeners and users to actually go to that one. So let's go to the next step, which is step 3 out of 7, which is a new feature that we incorporated, and this feature is called the tunnel shortening. This feature also came from our clinical users who actually wanted to have this opportunity to actually shorten or to stop the trajectories like anywhere within the applicator itself. Just to mention this, that in the previous versions of our software, the trajectories or the tunnels that were subtracted from these trajectories in which catheters or needles can fit went all the way through the applicator. So that was the only option. But now from the version 3.0, we have an option to actually shorten the trajectory and stop the tunnel anywhere within the applicator itself. And as I said, this came from our existing clinical users who want to use maybe not catheters, but maybe ProGuide needles or some similar products where they explicitly want the tunnel to stop within the applicator. So now we have this option and it's available. And as you can see, we can remove only the green nodes. The red nodes cannot be removed, which is kind of like I would say like a safety feature at one point, but also you cannot remove, if you start removing the nodes from one end, the other end is not, so you cannot remove any nodes on the other end, which means that, at least one entry point for the tunnel needs to exist. So these are all kind of like mini features that are incorporated into this new feature. And of course, within the new UI UX design, on the right-hand side panel, we can see these short tooltips for any of the new features implemented, where users can actually just quickly read what's the feature about and how to use it. And of course, our user manual contains all the detailed instructions on how to use all these features. Another new thing that we incorporated in the UI UX are these like undo, redo buttons, which are local, and you can always undo or redo the current local progress that you're making within any of the steps. But also you can go back to the previous step. And if you go back, you will be losing only the current process in the current step. Also, you can restart the whole workflow within one button and go all the way to the step one. Which we think is highly beneficial for users, to being able to go through steps and being able to go back if they use some feature in a sense that they wanted to use it differently. You don't have to actually go all the way to the start and basically lose time, your precious clinical time, and you just need to go back one or two steps, or how many steps you need to actually fix for something that you want to fix. So this new UI UX design, as I said, is another added value to this Surface Brachytherapy module, and helps clinical users to actually more efficiently navigate through the module. So let's go to the next feature, which is subtraction of the tunnels. But within this feature, we incorporated yet another feature, which we called countersinks, which can be found on the right bottom part of the panel, of the settings panel. So I'll just use this one, and you will see for yourself what it does. And what it does, it implements the cone-like endings on the exit part of the trajectories on both parts, on the both exit or entry and exit parts of the bolus, of the applicator. But what's this used for, like this feature? Why is it beneficial? So this feature comes from the 3D printing part of the whole process. We're having like an extensive, like 5,000 hours experience on our printers. We saw that sometimes the bottom part of the print may result in a little bit narrower tunnels than expected because of the process of the 3D printing, and the bottom part actually glued to the printing bed. So this issue, of course, came from our experience. But in mitigating this issue, we devised this feature where we can implement these countersinks, or these cone-like endings, where users can control the height and the radius of this cone, and just mitigate this narrowing of the tunnels on the bottom side of the printer bed, or the bottom side of the device lying on the printer bed. So as I said, this feature only has to do with the printing process, but nevertheless, it's again highly beneficial, as you wouldn't want to print any device more than once, ideally, and of course not lose time with the printer. So again, this feature will help in that process. So we go to the next feature and next step in our process. And I have to mention that all these steps can be also skipped. So we clearly see that some of the clinical needs do not require that you maybe have all these features implemented all at once and all at the same applicator. But if you do not need any of these features, you can click on the next button and just within 1 second skip this feature and go to the next step of the process. And the next step is 6 out of 7, which is a tunnel label setup, which means that we have incorporated an additional label for numbering tunnels. And again, anyone who is working in a brachytherapy facility knows that numbering the channels is very highly beneficial, and it's a very important safety feature, where all of the tunnels, or the tunnels need to be connected to corresponding channels on the afterloader. And of course, RTTs know the best, because they usually tend to connect these to catheters with the guide tubes with the afterloader channels. And of course, it's of a paramount importance that these tunnels correspond to appropriate afterloader channels. So incorporating these numbers is again a new feature that we kind of also find very valuable. And in collaborating with our clinical partners, we also, of course, found that it's very highly beneficial for them. And of course, me coming from a clinical background, of course, I can see that advantage. Of course, these numbers can be placed on any part, on any surface of the applicator. Also, I mentioned in the previous steps that we can use a local undo read or undo clear, so we can go back. We can actually we can change the position by clicking, grabbing, and dragging the number on top of the applicator, and change the place of these numbers. And when we are, let's say that we are kind of satisfied with the with placing of the numbers, we apply them. So the numbers will be indented into the 3D mesh, and your applicator will have those labels printed in. And you'll see in a couple of seconds how that looks like. So of course, I'm purposefully applying all the features at once for this applicator. Of course, as I said, any of the features can be skipped here. So this is how our applicator looks like. Of course, I kind of maybe over exaggerated these countersink radii, but that's just for the purpose of showing how it looks like and what it actually does to an applicator. And with the next button, we kind of exit the 7-step process here. And for those who are not really familiar with 3D Bolus app, I repeat again, and of course, this is something that's also contained in our previous webinars, that the ultimate endpoint or the ultimate export file that 3D Bolus app provides is twofold. Firstly, we can provide RT structure set, which contains the modified RT struct. What does that mean? That means that the designed bolus, and you can see here the modified structure with the tunnels, can be exported from 3D Bolus through this Export RT Struct button and can be re-imported back to the TPS for QA purposes, for commissioning purposes. So we kind of tend to aid medical physicists in the commissioning processes that occur regularly in radiation therapy facilities. And with these features, we kind of try to bridge the two worlds, the world of radiation therapy and the world of 3D printing through our software, and through these features like exporting the modified RT structure. On the other hand, we export the STL file, which is a 3D object of the device that we have just designed, which looks like this. And this STL file and its extension is compatible with all the 3D printing equipment and 3D printers ultimately. So these would be like the 7 steps and the new features that I wanted to show you today. And also, I will finish this presentation by quickly going to the post-processing features that we have, like cropping. Cropping is a highly beneficial feature because the bottom side of the device that will be ultimately facing the 3D printing bed needs to be completely flat. So this cropping feature is highly beneficial because we can just crop the bottom part, like just a millimeter or two, making the bottom part of the device flat, which means that your 3D printing is most likely to succeed, which is very, very beneficial in saving time. You don't want to print more, any device more than once, ideally. So again, some of these features, as I said, are beneficial for QA and commissioning purposes, but other features are highly beneficial in connection to the 3D printing process itself. So this was cropping, and in this version of the cropping, you may have seen that we have 2 cropping planes, and previously in previous versions of 3D Bolus there was only 1. With cleaving, we can just cleave or cut in half, or in 2 pieces. We can cut the applicator or the bolus, whichever module you're in. And this is also very useful because like in 2 scenarios. First, the print or the device, the applicator, can be very large in terms that it exceeds the build volume of your printer, which means that you can cleave in any kind of plane, in any kind of angle. You can cleave the applicator into 2 separate sides and print them separately, and then join them, glue them, tape them on the patient. So that's one use. The second use is if you have very challenging anatomies, like behind the ear or like the nose case, but with the nostrils printed, and something similar where you must cleave it in half in order just to fit the applicator on a patient. So that's another use case for cleaving that we saw with our clinical partners and users. So again, very, very useful, very, very useful feature. And again, then the very last feature, I would say, is the dosimetry, where we can embed the dosimetry pocket. So for in vivo dosimeter, where we can customize the shape and size of the pocket in terms that it can be cube or cylindrical, that you can change like the width, depth, length, well, in general shape and size of it, and that you can actually transfer any kind of reference points through DICOM RT plan from TPS to 3D bolus, and any reference points made in the DICOM, in the TPS will be transferred and placed here within this marker selection window. So, and of course, yes, so for the very end, maybe many of you have already seen, but we can incorporate like a patient label, which means that a patient label with the ID and name of the patient will be extruded on the applicator. So you can match the applicator to your patient and not lose the applicator or like misuse on the other patient. But that should not be the case, because our applicators are designed to be patient specific, as Rohit said, which means that we're using DICOM information and like specific anatomy information of the patient through DICOM RT structures to derive with the design. Yeah, so this would be the end of this presentation with the highlighted the new features and new workflow within the 3D bolus and specifically Surface Brachytherapy module. So without further ado, let's just jump to the Q&A. Rohit?
Yeah, thank you, Borko. It's a great overview of the new features and existing ones as well. So yeah, as you mentioned, we can go right into the questions that have come in from the audience. So let's start.